In this video, I'm going to talk about the upcoming March control test for Physical Sciences Grade 10. So that test that you'll be writing will be out of 100, at least according to the annual teaching plan. So it will be out of 100 and it will be 2 hours. So the first topic that test is going to be based on is transverse pulses on a string or a spring. The second topic is going to be transverse waves. The third topic is going to be longitudinal waves. And all of these topics combined typically will weigh about plus or minus 21 marks out of a possible 100. So it can be just above 21 or just below 21. The fourth topic will be sound waves. And that topic typically would weigh around 16 plus or minus 16 marks out of a possible 100. The fifth topic is electromagnetic radiation. And this topic will weigh about 20 plus or minus 20 marks out of a possible 100. Now you see all of these topics, number 1 up to 5, all of them in green. They carry, I think, around, if we add 21 plus 20 plus how much is for sound? Sound is 16, so we have 21 plus 20 plus 16. That is around 40, 57. So they carry about 60% of that question paper, of that paper that you'll be writing. More or less around 60%. And all of these topics, remember, they fall under this one big topic, which is sound, waves, and light. So that's where most of your attention should be focused upon. Now, topic number 6 will be electrostatics. So, and typically it would carry about plus or minus 18 marks out of a possible 100. Topic number 7 is electric circuits. This topic carries quite a lot of marks, so plus or minus 25 marks out of a possible 100. So the two topics, electrostatics and electric circuits, they fall under this one big topic. I think it's called electricity and magnetism. So if that goes, so you see they will carry around about 40% of your question paper. So now let's just try to break each of these topics into subtopics so that you know at least, or we try to approximate what is it that you are expected to know from each of these individual topics, from each of these 7 topics individually, right? So if we start with transverse pulses on a string or spring, one, you need to be able to define a pulse, a transverse pulse, and an amplitude. You need to know those definitions. You also need to state the principle of superposition. Sometimes the question won't explicitly state the principle of superposition. They might give you a scenario and say state the phenomenon that is demonstrated in the diagram above, or something like that. So you need to be able to state it in words. You need to also be able to tell us, to describe or to define what is constructive interference and what also is destructive interference. So this is based on transverse pulses on a string or a spring. If we move now to transverse waves, you need to be able to define what is a transverse wave, what is the crest of a wave, what is the trough of a wave, what is the wavelength of a wave, what is the frequency of a wave, what is the period of a wave, and also be able to define what is the wave speed. Know those definitions. You also need to explain what is it that we mean when we say points on a wave that are in phase or they are out of phase with each other. And additionally, if you're given a diagram of a transverse wave, you also need to be able to identify 2 points or more than two or more points that are in phase or that are out of phase. That is very important. Moreover, you need to be able to use this equation, which is the wave equation, to determine the speed of a wave. So you have V equals to small letter v equals to F times lambda for wavelength. So V is the speed, the wave speed, and F is the frequency, and lambda, that is the Greek letter lambda representing the wavelength. Remember, the speed must be in meters per second, the wavelength or the frequency must be in hertz, and the wavelength must be in meters. Those are the SI units. You need to be able to use this equation. Another equation that you need to be able to use is the one that relates the frequency of a wave to the period of that wave, which says that the frequency F equals to 1 over T. So T is the period, capital letter T denotes the period, and it must be in seconds. Remember, it's a time, it's a duration, and the frequency is in hertz. Now, if we move to longitudinal waves, what are the most important things that you need to know? You need to, one, be able to define what is a longitudinal wave, what is a wavelength. You see, some of these things, they repeat themselves. Yes. So what is a wavelength? What is an amplitude? What is the period? What is the frequency? What is the wave speed? And something new here, apart from longitudinal waves, is the compression and the rarefaction of a longitudinal wave. You need to be able to define those terms. The same way, similarly as with transverse waves, you also need to be able to use this wave equation. V, the speed V, equals to the frequency F multiplied by the wavelength lambda. And more than anything, you may be asked to state or to differentiate between a longitudinal wave and a transverse wave. So what are the differences between a longitudinal wave and a transverse wave? I've done videos on all of these things on this channel, so you can just scroll down the channel and you'll find these videos. And another thing is, with transverse waves, you also need to be able to determine the frequency F, which is equals to 1 over the period T. In terms of sound waves, one, you need to describe sound. You need to be able to tell us what is sound. You need to also be able to explain or describe what we mean when we talk about an echo. You need to tell us what type of sound is described or defined as ultrasound. You also need to tell us the benefits and uses of ultrasound imaging. One, you also need to be able to tell us the relationship between the speed of sound and the medium in which the sound is traveling in. So if it's traveling in a gaseous medium, or is it traveling in a liquid medium, or is it traveling in a solid medium? Is it slower or is it faster? So you need to be able to understand the relationship between the speed of sound in a gas versus the speed of sound in a liquid, or the speed of sound in a liquid versus the speed of sound in a solid. Also, even with this one, the wave equation, you need to also be able to determine the speed of a wave using the wave equation. One thing that you need to also know that is quite important, that I've seen in numerous question papers, you need to relate the pitch of a sound to its frequency. So you also need to know that there's a relationship between the volume of sound and the amplitude. And lastly, the quality of sound, or sometimes referred to as the tone to the waveform. And also you need to tell us about ultrasound imaging, where we use ultrasound to be able to image the insides. That doesn't sound nice. To be able to view the inside of a human, typically used for pregnancy, to examine the baby's development. So those are some of the things under longitudinal waves that you need to know. What about electromagnetic radiation? So one, you need to be able to list the properties of electromagnetic waves. You need to be able to arrange electromagnetic waves in order of increasing frequency or increasing wavelength, or decreasing frequency or decreasing wavelength. So you need to know, go look at that electromagnetic spectrum. You also need to use the wave equation, but see here, instead of v, we have the speed c, which is a constant. You also need to know what is the value of that constant. So c equals to the frequency f times lambda. You also need to tell us what is the use of each type of electromagnetic radiation. What is the use of X-rays? What is the use of ultraviolet? What is the use of, infrared, gamma rays? All of these things you need to be able to know at least one use for each of them, right? We also need to know something called the penetrating ability as it relates to energy. So if it's a wave has a higher energy, it has a higher penetrating ability, such as gamma rays. And also be able to tell us what are the dangers of gamma rays, what are some dangers associated with gamma rays and X-rays, and also tell us about the damaging effects of ultraviolet radiation or UV radiation on our skin. Like I said, the videos are available. Go through them. I've mentioned all of these things. You also need to be able to define the term photon, right? And now also you need to tell us what is the relationship between the energy of a photon to the wavelength and the frequency. So what is the relationship between the energy of a photon and the wavelength? Are they directly proportional or are they inversely proportional? So those are the type of things that you need to know in terms of electromagnetic radiation. And also you be able to use this equation, be able to determine the energy of an electromagnetic radiation, which is given by E equals to HF. E is the energy in joules, H is Planck's constant. You need to know what that constant is, and frequency is frequency in hertz. Or this also formula can be rewritten as Hc, E equals to Hc over lambda, where lambda is the wavelength. Now we go to electrostatics. In terms of electrostatics, you need to be able to tell us that negative electrons carry negative charges, and positive charges are carried by electrons. You need to tell us what we mean when we say an object is neutral or uncharged, what you mean when you say an object is positively or negatively charged. You need to also tell us about triboelectric charging, when we rub materials, two different materials together, and there's the transfer of charge. You also need to tell us the SI unit for charge. We'll find out what is the SI unit. Maybe you know what it is now as I'm speaking about it. Additionally, this principle of charge conservation, that formula Q equals to Q1 plus Q2 divided by 2. So when we have two identical charges or two identical spheres, they touch and then they will share the charge amongst them, such that at the end they have equal charges. And another one of this equation under electrostatics is the one for charge quantization. Q equals to N multiplied by QE, where QE is the charge on an electron or the charge on a proton. So if it's an electron, that value will be negative. If it's a proton, that value will be positive. So all the other charges, all the charges in the world, they are an integer multiple of this QE value. That's why we have the charge quantization expression. and then also be able to tell us opposites attract, like charges, they repel each other. We talk about the repulsive force, then the attractive force. Now, under electric circuits, which is the last topic that you will be tested upon, you need to define potential difference, electric current, resistance, 1 coulomb, EMF, and potential and terminal potential difference. Go memorize what those definitions. And also you need to tell us and indicate on a circuit diagram what is the direction of conventional current. And you need to also know how do we actually connect a voltmeter and an ammeter in an electric circuit. Do you connect it in series or do you connect it in parallel? So those are some of the things that you need to know. And lastly, you need to know these two equations. You need to know how to work with them. The formula or the expression for potential difference, which is potential difference V, equals to the work done divided by the charge, or the current, which is the current I, equals to the charge divided by the change in time, or delta T. So like I said, this paper, according to your ATP or the annual teaching plan, will be out of 100. It will carry 100 marks, 2 hours. You might have about, let's say, maybe 6 questions. So the first question is, it's multiple choice, 10 questions, each question carries 10 marks. So for multiple choice already, that's 20. Then you'll also have the structured questions that will be based on these topics.